For years, the whole game in AI has been pretty simple. Bigger is always better. If you wanted a smarter AI, you just had to build a bigger model, throw more data at it, and have a ridiculous amount of computing power. But what if that's not the whole story? What if a much, much smaller model could step into the ring and compete with the heavyweights?
Okay, so check out this chart from Artificial Analysis. Over on the right, you've got all the usual suspects, right? The massive heavyweight models with hundreds of billions of parameters. But now, look way, way over on the left. See that dot? That's Apriel. It's sitting in what they call the most attractive quadrant. Basically, it's delivering top-tier smarts from a tiny, tiny footprint. The big question is, how on earth is that even possible?
So, to really get why Apriel is turning heads, we've got to talk about the huge problem it's trying to solve. I'm talking about this invisible wall that's been built around the most powerful AI.
Yeah, this whole bigger is better thing, it's created a massive gap. For most companies, for universities, for small research labs, building a cutting-edge AI it's not going to happen. The cost for these giant computer clusters, not to mention the energy to keep them running, is astronomical. It basically locks the future of AI innovation behind a really, really expensive paywall.
But now, this new model from ServiceNow's AI lab is stepping up to challenge that whole idea. So, let's meet Apriel.
So the key is right there in its name, 15B. That stands for 15 billion parameters. You can kind of think of parameters as the little knobs and dials an AI uses to learn and reason. And this model is making a claim that sounds, well, almost unbelievable. It's saying it can go toe-to-toe with systems that are 10, maybe even 20 times bigger. Oh, and it's not just for text, it's multimodal, so it gets both words and images.
I mean, just let that number sink in for a second. 15 billion. The giants it's up against, they have over 100 billion parameters. Some are even pushing into the trillions. So this isn't just a little bit smaller, it's a whole different ballgame when it comes to efficiency.
So the question is, how in the world did they pull this off? Well, the secret isn't just about shrinking the model down. It's about training it smarter. And that's where this really clever idea they call mid-training comes into play.
Yeah, this quote from their paper is basically their entire philosophy. See, instead of the usual brute force approach, just cramming a model with insane amounts of data from the very beginning, they focused on this crucial and often ignored stage in the middle, the mid-training phase. They believe that's where the real magic happens for building reasoning skills without all the waste.
So here's the game plan. It's this 3-stage pipeline. And what's really smart is they didn't start from scratch. Nope, they took a model that already existed and just built on top of it, layering on more and more complex reasoning skills with each step. Let's break down exactly what they did. All right, so first up, instead of building from scratch, they used something called depth upscaling. It's a bit of a fancy term, but it just means they took an existing open source model and expanded it, making it smarter without that huge upfront cost. Then comes the really critical part, continual pre-training. You can think of this like sending the AI to a specialized grad school, where they're feeding it very specific, carefully chosen texts and images to beef up its reasoning abilities. And finally, they fine-tuned it on over 2 million high-quality examples where the AI literally had to show its work, explaining its thinking step by step. And maybe the most impressive part of all, they did this whole thing without using any of those super expensive and complex reinforcement learning methods.
Okay, that all sounds really clever in theory, but does it actually work? I mean, can a 15 billion parameter model really hang with the big dogs? Well, let's look at the numbers.
Just take a look at this leaderboard. You see Apriel right there? It's scoring a 52. That puts it right in the mix, neck and neck with models that are way, way bigger. In fact, it's even beating giants like Llama Nematron, which is over 3 times its size. This chart is basically the proof in the pudding of just how efficient this thing is.
And if you need just one killer statistic to really drive the point home, here it is. 87%. That's its score on a competition-level math benchmark. And we're not talking about simple addition here. This is the kind of super complex, multi-step reasoning that you'd think only the biggest, baddest models could pull off. Honestly, that's an incredible score for a model of any size, let alone one this compact.
I mean, this quote from the developers just says it all, doesn't it? To get this kind of performance, any other model out there needs to be at least 10 times bigger. This isn't just a tiny step forward, it's a huge leap in efficiency. And that right there is what makes this model a potential game changer.
So, okay, the benchmarks are impressive, but let's get down to it. What does this actually mean in the real world? Why does a small but powerful model like Apriel really matter?
Well, the biggest thing is just accessibility.
It's huge. While the giant models need these massive, super expensive data centers, Apriel can actually run on a single, powerful GPU. Think about what that means. Companies can run it themselves, on their own machines, keeping all their data private. It just crashes the cost of entry for using top-tier AI and starts to shift the entire focus from this brute force race for size to a much smarter approach focused on quality training.
And look, it's not just about what the benchmarks say. People out there in the open source community are really starting to notice. I love this comment from a Reddit user. It just captures the vibe perfectly. It punches way above its weight class. That's the real-world validation, you know? It shows the performance isn't just some theoretical number.
But, okay, it's not all sunshine and roses. Not everyone is convinced. Other users have found that it kind of struggles with some practical day-to-day tasks. One person suggested its intelligence might be smoke and mirrors. You know, great at passing tests, but maybe not so useful in the real world. Some have even pointed out that it has trouble following specific instructions.
And all of this brings us to the really big question, right? Apriel has definitely proven that a smarter training approach can let a small model compete with others 10 times its size. It's a direct challenge to that bigger is better idea that's dominated AI for so long. So, is this just a lucky punch, a one-off? Or are we actually seeing the beginning of a whole new era in AI where smarts finally start to beat pure scale?